Find the amplitude, the period, and the phase shift, and sketch the graph of the equation y equals 6 times the sine of pi x. Well, the amplitude of the curve can be found by looking at the lead coefficient of the sine, so the amplitude will equal 6 units. The period is found by taking the coefficient of the argument of the sine. This is the argument in this case is pi times x. Take that coefficient pi and use that as the denominator in a fraction that has a numerator of 2 pi. So the pi's in this case cancel out and we just have a period of 2 units. That can also be seen by looking at the interval 0 is less than or equal to the argument pi x is less than or equal to 2 pi, and solving for the range of x values it will take to make pi x range from 0 to 2 pi, which would give a full cycle of sine. If we divide it through by pi, we see that we have 0, because 0 divided by pi is 0, less than or equal to x, less than or equal to 2, and so as x ranges from 0 to 2, we'll trace out a full cycle of sine, and that means that the period, which is the distance from here to here, from the start of a cycle to the end of a cycle, is 2 units. There is no phase shift in this case. If there were a phase shift, we would find it by by inspecting this number, the number in the on the left-hand side of the interval that I've transformed by solving the argument, solving for the x value when the argument was in between 0 and 2 pi. So the phase shift is 0. This can also be seen if we had a plus c term here and we call the coefficient of x b, then the phase shift can be found by doing the opposite of c divided by b. In this case c is 0, so we have the opposite of 0 divided by b. Actually b would have been pi, but regardless that gives us 0. So and that's another way we could show that the phase shift was 0. So we have the three components that were asked for. We have the amplitude, we have the period, and we have the phase shift. We can sketch a graph of sine now. The sine curve generally goes between -1 and +1. Since the amplitude is 6, it will now go between -6 and +6. The phase shift of 0 means that the curve will start at the origin. What I'm going to do is graph the sine over the interval that I solved for at these two steps. And I'll start at 0 and I'll go out to 2 units, 1, 2, and that the fact that the period is 2 and that happens on the interval from 0 to 2 tells me a good idea of how to graph this curve. The sine curve has a shape that starts going up, comes down, and ends back at 0 again. It has a 0 halfway in between the two endpoints of the period, and it has a maximum and a minimum halfway in between each of the zeros. So I'm seeing that on the graph that I'm going to sketch, the sine curve is going to start here, it's going to end here, it's going to have a 0 halfway in between, so 0 at 1, and its maximum will occur at 0.5, and its minimum will occur at 1.5, and the max and mins will be 6 units above or below the x-axis. So that gives me a good sense of the shape of this portion of the sine curve. I could continue to build copies of this sine curve. I can see that 1, 2, 3 will be another 0, 4 will be another 0, and that, as before, the maximums and minimums will occur on each half tick mark. Could go backwards as well. At -1 there'll be a 0, -2 there'll be a 0, and halfway in between those integer values I'll have maximums and or minimums depending on how far along I am. So that's a good portion of this sine curve, and we could continue to sketch additional cycles if we had a reason to do so.